Greetings, hatchlings. Today's lesson is the A-star algorithm. Now, I know it sounds like it's a more complicated algorithm than it really is. It's not that hard, actually. So here's the basic concept. You've got a grid. Now, on this grid, you're going to either store passability information or perhaps, some kind of terrain value saying it's hard to go through this, but not that, or whatever, right? So the heuristic will usually do one of two versions. Either distance and is it passable, and distance value. Right? Either heuristic for, then of course, sorting it into two lists. You start with your first one, you find all the possible nodes around it, throw them in the open list. And then find the first one in there sorted by its value, right? Using the heuristic. Sort the value, and then you find the top one, pop it off. Do the same thing, so that's this one, right? Find all its values, throw them in the open list, throw this guy into closed list, right? And now, for each of these guys, you scan. Well, the first one you pop the first one off, right? Every time you pop one off, you always check and see if it's in the closed list. If it's not, you're fine. Okay, so you keep doing that. You keep following these guys. They always keep trying to get closer and closer. The one with the lower value is better, right? So, lower terrain value, lower distance. You want to go to that node next. It's always putting them in these lists that's prioritized. You really need a priority queue or something like that for this to work well. So, they go into the list and they get sorted. And it's always popping the top one off. The top one should always have the lowest value. So, it's technically searching all possible values. But it focuses its search on just the closest ones first. So, if it can't find a path by the closest ones, it'll try all the other ones too. Till finally, the closed list has all the nodes. The open list is empty. It would return it couldn't find a list. Right? Now, if it did find a list, what you have to do then is follow the nodes back from their parent to the start. Now, a good trick to reverse this list for when you are actually going to use it to follow the path would be to, as you're collecting the list, inversely traverse an array, popping each one of these values into the array slot. It's simple, effective, and saves you some hassles when trying to use the data later. You could also just follow the list in reverse too if you wanted, but this saves you the hassle of remembering that. It's pretty easy to implement too. Of course, as always, hopefully you've learned something.